Hello and welcome to my channel. If you have over 6 years of experience in Java and microservices, please don't skip this video because performance optimization in microservice architecture is a common and critical interview topic. Now, this video is part 1 of the two-part series. Here, we will focus on troubleshooting performance issues, and in the next video, we'll dive into fixing and optimizing them. So let's get started. Now, this is a high-level microservice architecture commonly used in distributed system. So let's see what are the basic components here. This is a microservice architecture of an e-commerce application. We have the client as a mobile app, web apps. These are the client interface which interact with these backend services and they communicate using either JSON or HTML. Then we have the API gateway, which act as a single entry point for client requests. It handles tasks like request routing, load balancing, and authentication. These are the different services, individual services like inventory, payment, order, and authentication services, which are decoupled and handle specific business functionality. And each service has its own database for isolation. Then we have a service discovery, which allows services to find and communicate with each other, and the management, which oversees the operational aspect like configuration and orchestration. Uh, then we come to this Kafka or RabbitMQ, which is a publish subscribe channel is used for asynchronous communication between services. And this enables sending messages or event between services for task and notifications. These are the notifications. Then we have a monitoring and logging tools. Uh, for monitoring, we are using Grafana and Prometheus, which monitors the performance and health of our application. And if we have a centralized logging system, which is using ELK Stack. ELK stand for Elasticsearch, Logstash, and Kibana, which is used for uh, aggregating all the logs of the different microservice and for analysis. And here we see that we are using CDN, which stand for Content Delivery Network, which is used for serving static content. Now, these days we are getting this question in a lot of interviews, like how to troubleshoot performance issue, like slow response in microservice application. So let's see what could be the answer for this. So if you get a question like this, you shouldn't jump to the microservice at the very beginning. The valid first step is to see in the client side whether the issue lies in the client side, and if everything is fine, then you should go to the backend side. It's not always that the issue lies in the backend. So first you should see the network latency. That is a slow network connection on the client side, such as high latency, poor bandwidth, or packet loss, which is causing delay. You can use tools like ping or traceroute to measure the connection from the client to the microservice server and identify any significant delay. Now, you can use the browser developer too. Let me show you. Like I have opened my browser, Chrome browser. You go to inspect, and this is the developer tool where you have various tabs called network. If you are clicking on anything, you will get all the data, status, how much time it is taking. Then you have other tabs called performance. And if you have installed the Lighthouse, which is an extension to the uh, Chrome browser, which will give you a full analysis report. Analyze these report and get to know what exactly is the issue. Now you can open the network tab in the browser tool. You can measure the time it takes to make request and receive response, including time spent on DNS resolutions. connection setup and server processing, and look for usually long request response time, failed request or retries. Next is you can inspect the asset size. If you are fetching any images, video, uh, they could be a very huge. So look for unoptimized images or resources that are large and delay rendering. Tools like Lighthouse, as we have discussed, or PageSpeed's Insight can help identify these issues. Now, you can access your microservice with different type of browser, different type of devices. Your client could be different. So the performance issue could be browser specific. Test on different browser like Chrome, Firefox, Safari, and ensure there are no compatibility issues. And there could be a device specific performance also. The client device, especially on mobile, could be limiting factor. Test on different devices. Example, low end versus high end smartphone, desktop, and mobile to see if the issue is specific to particular hardware. You can measure API request parameter. So the data being sent from the client could be too large. Check if the client is sending excessively large payload. Payload is the data. Like suppose uh, this data which I am sending, it could be very huge, which might cause the issue. Try reducing the size of the request. Then there are header and authentication, which we sent along with the data. So incorrect or unnecessary headers like large cookie, redundant and authentication token. Let me show you. If you are sending any authentication token like or headers, don't send incorrect or unnecessary header, which could contribute to slow request. So first analyze the header to ensure they are optimized. The next is identify client-side rate limiting. Now, first let's see what is rate limiting. Uh, Rate limiting refers to the restriction or control on the number of requests or action that can be made to a service or system in a specific time frame. So, in order to avoid abuses or to control resource usage, we use rate limiting. Now, for example, if in an API, a rate limiting might restrict the user to 1000 requests per hour. So once that limit is reached, the user will receive an error response. So this could also be one reason for performance issue. So if the client is hitting rate limiting, either on the backend service or any intermediate service, requests might be delayed or throttled. Check for the API rate limiting errors. This is configured in your application in the response header. The next thing which we can do is test with different client location. So if your application is global, like in our case, if the user are spread across different geographical location, the performance might vary due to server's distance because of high latency. Test the performance from different region to check if network latency is affecting the response time. And if you are using a CDN, as we are doing in our case, now what is a CDN? CDN stands for Content Delivery Network, which is a network of distributed server designed to deliver content, static content such as web pages, images, videos to users more efficiently based on their geographical location. So if you are residing in Mumbai, these static content will be delivered to you from the uh, edge location, that is a nearest server to Mumbai, not from Australia. So CDN improves website performance by reducing latency, speeding up content delivery, and enhancing the overall user experience. So if you are using a CDN in your application to cache assets or API response, make sure that it's working as expected and the client is fetching resources from the nearby edge server. Edge mean nearest server. Now you have done everything from the client side and you were not able to troubleshoot any issues in the client side, then we'll move to the backend, that is the microservice. So the first thing which we can do is have a monitoring tool here using Grafana and Prometheus. So we can see the performance and the health of our application using this monitoring tool. So we can monitor and analyze performance metric using, like in our case, we are using Prometheus and Grafana, but there are other tools like Elastic APM, Dynatrace, and Datadog, which you can use these also in your application, which collects all the metrics. So what metrics they provide us? Response time, that is the latency, throughput, request per second, error rates, and resource usage, that is CPU, memory, disk, and network. So we can see this is just a sample of a Grafana dashboard. We can troubleshoot our issues, that whether there is a latency issue, or we there is a memory issue, or our application need high processing. Next is enable distributed tracing. Now, what is tracing? Now, tracing in microservice refers to the process of tracking and recording the flow of requests as they travel across the various services in a microservice architecture. So, if you have a request something, the request will flow to various microservice, and then you will get the response. So, that flow is the traces, and if you want to keep track of these traces, then we use tools like jgear, zipkins, because there could be some issue with the communication between microservice in between the request. Suppose the request is flowing through five microservice, the communication between third and fourth, there could be some issue. So how we are going to find that? So we will use certain tracing tools like jgear, zipkins, or aws x-ray to trace requests across the entire service chain, where we can analyze where the most time is spent, services, database, or the third party API, and identify which microservice or part of the code is the slowest. Next thing is we can check the logs. We have a centralized logging tool in our application, like in our sample architecture, we were using ELK stack, or you can use Splunk also, which aggregate all the logs from all the microservices. Here we can look for exception, timeout, and retries. This is a sample dashboard of a Kibana where we can search all the logs and troubleshoot what exactly could be the issue. Next, the issue could be inside the code also, a Java code. So we can use profiler like YourKit, JProfiler, or Visual VM to find inefficient code and bottlenecks in loops, object creation, or garbage collection. So let me tell you about JProfiler, what it is used for. Now, JProfiler identify the performance bottleneck in your application. It diagnoses memory leak and inefficient memory usage. It also analyzes multi-threaded. If your application is multi-threaded, it can detect issues like deadlock and optimizing database interaction and reduce query execution time. Now, generally, JProfilers are used to find the memory leak in your program. Now, what is a memory leak? It occurs when a program failed to release any memory that is no longer in use. Those objects which couldn't be garbage collected, though they are of no use to us. How does it happen? Unreleased object reference, or failing to close any resources like database connection of files or network. If there is any circular dependency, cyclic dependency between objects, improper handling of caching. Storing too much data in memory without proper eviction policies can also cause memory leak in caching system. So you can find those issues using JProfiler or Visual VM, and you can then refactor your code accordingly. Your issue could also happens because of some external dependency. Like if there is any slow queries, then you have to use some database specific tools like SQL Profiler or Explain Plan, which will find all those slow query And if you are using a lot of connection, database connection, they could be the connection pool gets exhausted. Because of that also, your response becomes very slow. You're using any third party API which is giving you a slow response. So you just see that the retry and timeout configuration in your code is proper. If you're using any messaging queue, like in our case, we are using Kafka or RabbitMQ, check for delays in message processing. And you're going to check that in the specific log. Now, the issue could be because of the infrastructure of your microservice architecture. You need to verify whether the auto scaling policies of your service is proper. Now, if you're using auto scaling in your application, then you have to write some auto scaling policies also. Why do we use auto scaling? Because auto scaling helps maintain the performance of the service by dynamically adjusting the number of resources, such as instance or container, to meet changing demand. So, in high traffic, you will have more instance of your microservice. So, you need to verify whether the policies which you have configured in your application, uh, it's proper or not. Then you can identify high latency between microservice and look for drop packet or network congestion. You can also troubleshoot the issue by simulating and the load test. Now you can use certain tool like JMeter, Gatling and K6. I'll tell you about JMeter, which is a web application testing which simulate multiple user accessing a web application simultaneously. So it validates whether REST or SOAP API which you are using, how does it perform under various load condition. It also does the stress testing that push system to the limit to determine maximum capacity. And it also does endurance testing. That means it assess how system perform under continuous load over an extended period. So the issue might be because of high load. So you can troubleshoot that using these tools. Now you use certain design pattern in your microservice. One is circuit breaker pattern. A circuit breaker pattern is a design pattern used to detect failures and prevent a system from making repeated call to a failing services. So it prevents the cascading failure. If one microservice A is calling microservice B, if B fails, then it should not respond you with an error. You should mention certain fallback method for that. Like in this example, we are calling some external service using a REST template. If by chance this service fails, instead of giving an exception, we will call a fallback method, which will give you a very client friendly kind of response. So you should check the configuration of your circuit breaker pattern. And if you're using caching also in your system, then ensure frequently accessed data is cached effectively. All those eviction policy and all you need to check. And if you have configured timeouts and retry in your application, then you should optimize timeout and retry policies to avoid any slowness. So these were some steps you can take to troubleshoot performance issue. In our next video, we'll cover how to optimize a microservice for better performance. If you find this video helpful, don't forget to subscribe to the channel. Thank you.